Hi friends, welcome to EETECQONE. In this video, we have to discuss about the root mean square value. So before going to the RMS value, we already know the average value of AC signal. So in this AC signal, we have to find out the I average and then V average. So like this, only slight difference in this root mean square value. So what is the root mean square value? The average or the RMS value of alternating quantity is defined as the AC value of current flowing through a given resistance for a given time produce the same amount of heat as produced by the direct current when flowing through the same resistance for the same time. So this is the basic definition of root mean square value. So it's a simple one. We have to know about the what is the root mean square value of current and then voltage for the AC signal or instantaneous value of AC signal or AC. We have to know the steps, what are all the steps to find out the RMS value. So first point, write the equations of an AC quantity, observe the various time intervals. Quantity means parameters like this current, voltage, whatever may be. Second point, find the square of the AC quantity from its equations. Third one, find the average value. So average is equal to area of curve over one cycle of squared waveform. So in the squared waveform, we have to know the what is the portion of this squared waveform divided by length of the cycle. So total length of the cycle, it's called as the 0 to pi. So in this value, pi. Fourth point, find the square root of average value which gives RMS value. In this value only we have to find out the RMS value of voltage and current. Let us consider the sinusoidally varying alternating current and square of this current. So in this waveform we have to know the various two different various sine waveforms are there. One cycle is complete cycle. So like this, I is equal to Im sin theta. So in this waveform 0 to pi, it's a one cycle. Again pi to 2 pi, the negative cycle will be there. So in this called as the total cycle, it's called as the normal I value, that is called as the I is equal to Im sin theta. So I have to draw this waveform again. So you already known what is a sine waveform. And then squared value means the positive cycle again will be repeated. So second cycle I have to draw this like this. So this one is the squared value of current. So it will not have the negative cycle of the portions. So it will be again squared into the positive cycle only. So that is called as the I squared equal to Im squared sin squared theta. So formula like this, I squared is equal to Im square sin theta square. This is the difference between the square value and the normal current value. So let us square value, we have to take the one stripe value. So that is called as the d theta. From this waveform we have to write the basic average equation and then find out the Vrms value. So this is the basic sine waveform. First point, the current, we already know I is equal to Im sin theta. If it is voltage, V is equal to Vm sin theta. This is the basic equation. Square of the current, I squared is equal to Im squared sin squared theta. Next, area of the square curve over a cycle. So positive cycle. So that is called as the 0 to pi limit. It's a one cycle. So that is called as the 0 to pi I squared d theta. If it is one cycle, full cycle means 0 to 2 pi. This is the difference between positive cycle and negative cycle limit. Third one, average value of square of the current over a half cycle. So is equal to area of the curve, that is called as the stripe value. So we have to take it divided by length of the base. Length of the base means total cycle for positive cycle. So it's called as the value 0 to pi I squared sin squared theta divided by length of the base is equal to pi. From this equation we have to find out the what is the value of I squared sin squared d theta divided by pi. So in this equation, the I squared Im is a constant value. So we have to take it out. Im squared, it's a separate one, 0 to pi sin square theta divided by pi. So Im square divided by pi is a constant portion. So we have to write the formula for sin square theta. So we already known sin square theta is equal to 1 minus cos 2 theta divided by 2. So this is the formula for sin square theta. So we have to write Im square divided by pi. Instead of sin square theta, we have to write 1 minus cos 2 theta divided by 2. So constant portion we have to take it value out. 1 minus cos 2 theta divided by 2. So in this 2 we have to take outside 2 pi. From this 1 minus cos 2 theta only we have it. So now this we have to integrate the value of cos 2 theta. So we already known cos 2 theta is equal to formula of sin 2 theta divided by 2. So we have to substitute or we have to integrate cos 2 theta is equal to sin 2 theta divided by 2. So instead of 1 we have to integrate, the value will be theta, and then cos 2 theta integrate means sin 2 theta divided by 2. So we have to substitute the 0 to pi limit. So pi instead of theta, it will be called as the pi. So we have to substitute pi minus sin 2 pi divided by 2. So theta we have to substitute instead of theta. So sin 2 theta divided by 2 minus, so 0 will be 0 always, sin 0 divided by 2 0. So that is called as a common 0. So from this equation, sin n pi will be 0 always. So this is formula. Sin 1 pi, 2 pi, 3 pi, 4 pi up to n pi, the value will be 0. So we have to only have the pi value. So finally Im square divided by 2 pi into pi, the both the pi get cancelled. So Im square divided by 2 is the average value of root mean square value. So we are getting final Im square divided by 2. So we want to know the value of voltage, means voltage average is equal to Vm square divided by 2, the same value. So let us find out the root mean square value. In this formula, Irms equal to square root of mean or averages of square of current. So square of current we find out. So square root of Im square divided by 2. So Im square, then root will be get cancelled. So the finally Im divided by root 2. So we already know the value of root 3 and then root 2. Root 2 we know the value of 1.1. So 1 by root 2 value will be 0.707 Im. So Irms equal to 0.707 Im. This is the RMS value of current in this. Next one, the same Vrms. Vrms equal to average square of voltage. So in this value, Irms equal to current, Vrms equal to voltage. That's the difference. So square root of Vm square divided by 2, square root and then square will be cancelled. So Vm divided by root 2. 1 by root 2, the value will be 0.707 Vm. So like this, if you have find out the Irms value, means directly write into the Vrms value. So similarly, average value for this video. So it's a root mean square value also same. So Vrms equal to 0.70 Vm. So if you have any doubt, you go through the average value video. Next, form factor. Form factor is equal to RMS value divided by average value. It's a formula. It's a basic for some problems. It will become form factor. FF is equal to RMS value divided by average value. So this is the KF. Next, peak factor or thrust KP. So peak factor value KP. Peak factor is equal to maximum value divided by RMS value. So in this waveform, maximum value divided by RMS value. It's the peak factor Kp is equal to, for example, for sinusoidal varying voltage and current waveform, the maximum value of current is equal to Im divided by RMS value 0.707 Im. So finally we are cancelling Im divided by Im. So Im will be Im get cancelled. Finally 1 divided by 0.707 have, and then we have to calculate, it will be 1.414 for sine waveform. So this is the constant value of Kp. So Kp for 1.414 for sinusoidal waveform. I hope in this video is very helpful for your clarification. If you have any doubt, please comment me. You are really like this video means share your friends and then subscribe with channel. Thank you.